Okay, so here's our second shortcut rule that we can use to help simplify some of these derivative problems. So it's called the sum rule, and it's pretty straightforward. It basically says that when you add two functions and take the derivative of them, that is equal to the sum of each of their individual derivatives. So let's look at a quick example. If f of x is given as x squared plus x, we can treat this guy, the x squared, and the x as separate functions. So we can take the derivative of x first. The derivative of x is 1, right? So the reason the derivative of x is 1 is if we take the power rule, we say d of x to the first equals, so n equal 1, and then we get 1 times, following this formula, x to the 0. X to the 0 is 1, don't forget that. So that equals 1. So that's how we get this first derivative. And now what we can do is by using the sum rule, we can take this first function separately and take the derivative of that separately. So now what we'll do is we'll take the derivative of x squared. So in this case, n equal 2. And then we'll plug in the formula. So n equal 2 times x to the n minus 1, which is 2 minus 1, so that's 1. And so this will just equal 2x. Okay? So now we put 2x down here, and we know that this, so now we've got f prime of x. So we've taken the derivative of each individual function, and now they get added together just like we did here. So your final answer so now you've used the power rule in this problem, and you used the derivative sum rule. So the derivative of this guy is going to be 2x plus 1. So it's pretty simple, but this needs to become second nature. So anytime you see two functions added together, to take the derivative of each individual one and then just add them back together. So this also works for, don't get confused if you see a minus. So if it's f of x equals x squared, it's kind of a separate problem. So x squared minus x. This also applies, but in this case, if we use the formula, you're going to treat this as x squared plus minus x. So in this case, your derivative here is going to stay 2x, like we did up here. But your derivative of this negative x, it uses you can follow the same formula, but the negative just stays there. So you get minus, and then you still get the derivative of, so you get minus 1. So in this case, you get something like this.